Welcome to a new test and teardown video. So this one is a capacitance meter. That's actually all it can do. It's from ECD and it's just called a C meter. So this is Instrotech. It's a local importer of all sorts of cool equipment. This is from USA, and I guess this is from 1999, somewhere around that. So this case is a standard electronic do-it-yourself case or whatever. You can buy this case for your own products, and I guess this is what they kind of just did, and milled some holes and put on this glue aluminium label. And it comes with a very practical, maybe this is not a standard equipment, or this is, because it doesn't really say exactly the same, right? So it's Gray Hill. So this is probably a test fixture, standard test fixture that just happens to fit. So now you can measure much easier, just stick in the capacitors. There's definitely a problem with the LCD. We got those funny lines, and I don't know exactly how to get rid of that yet. But I will of course open this and see if I can clean it. See, if I push the button, it goes straight to picofarad. And it seems like it is actually working. Let's see, hold this and then dial. I can dial it to 0. So it is, what, 2 times a second or something like that. So if I do that, and if I take a capacitor, where is it? So this one says 2, 2, and 1. So that is 220 picofarad. So how can I hold this with one hand? A second. Oh, I just got my camera holder. It is that easy. See, 2 hands, yada yada. So let's hold this in and let's stick on the 220 picofarad. Look at that. So it is spot on. And of course, this is my reference capacitor. I know works. So it just happens to save these kind of components. Normally there will be plus minus many %, but this one is very, very accurate, and that's why I kind of keep it a safe place. Ah, funny, right? So what I think we should just try and do and open this and have a look. I really like it when people add those notes when they install batteries and they wrote a date. So that is good. Thank you very much for doing that. Super good style. Obviously, we also need to tell people to please take out batteries from stuff you plan to store for a long time, or you don't plan to use it for the next month or years or what not, because batteries, they kind of tend to puke themselves into electronics and destroy everything. So that is why I really want to see batteries removed. So please remember to do that, all right? Oh, come here. Ooh, that is some sticky stuff. Oh, what exactly is that? We got a lamp? Really? I did not expect. Ooh, look at that. We see some batteries. And what do I also see? Some pukety puke. Down there, some liquid stuff. So that is definitely that we need to look at. But what the? There's a bulb. What if I turn on, push the button? So maybe this bulb is in series with the capacitor. Is this a protecting device? We also got some tape, and what is this? I kind of did not expect. Really? Ugh. So, okay, I need to unscrew here to get more. What is this bulb doing? I really want to see if this unit still works when the bulb is removed. That has to be fun. Okay, let's put on this. Okay, and we are trying again. Oh, look at that. Now it says some really weird crap values. So what, this bulb is a thing. Please tell me what the heck is the idea. So there's a funny bulb in here, now it's mounted, and then it goes 0. What? Okay. Really? I have not seen anything like that before. I unscrewed the 4 little screws here in this PCB, and there was of course a nice interconnect to the other PCB. And what do you know? This thing is full of CMOS ICs. Wow. What is that little funny thing? Op amps and all sorts of stuff. This is very, very full of stuff. I didn't expect it to be that packed. And then, okay, so this is power input. It even says plus minus here. So this is all right. But then, this is how they did it. So this is the top board. Again, it is super, super packed. And then gaffer tape, or duct tape as you call it. And there's metal in here and a wire for shielding around the input. And again, this funny, funny bulb. Got some trimmers. But I think we really need to unscrew everything here and get down to the bottom of the display. How is this interfaced with the LCD? Because there's definitely something wrong with the LCD, and it still kind of works when it works. But this has something to do, as you can see, some mechanical stuff that is probably pushing too hard. See, if I push a little bit on the display, then it goes worse on this. So there's probably a mechanical assembly problem here. So this is what I need to address. Also, I need to really note exactly where this little white wire here is soldered, because that is definitely gonna fall off for me. I should probably just desolder it and then continue my work. Okay, so now it is out here and we can actually see 1976. So now we know how old it is. Maybe we could also have seen this. No, we cannot see exactly that on the ICs. This one is from 76. You will see some 72 or 73 and 70 markings on the ICs. So a normal good trick when you want to date stuff is just search all the ICs for the latest. That one says 77. So that is probably the latest. So this PCB is version 1976. All right, let's open it a little bit more. So now we're all the way in. And as you see here, this is kind of the holder. So it attaches to each side of the glass, and then all those contacts, they push against the glass for contact, right? So this means this glass is actually bent a little bit due to this way that it is supported. Wouldn't you say that? So what is going to happen if I push a little bit here in the middle? That means I'm going to try and change the way that the glass is bent. That is what I would guess. Ooh, that seems to have See, that actually makes it go away. Or at least change it a little bit. So I guess I don't know what else can I do with this. When I push it a little bit, it is definitely because there is some mechanical stress or something to this glass, or just time passed and then the glass kind of bent a little bit. But you see, when I push and let go, then ooh. So this is a bend kind of problem. All you see here is actually the dust from the hole in the plastic. So this is, what is that? That's probably another kind of, that is just the hole for this. Okay, there's another one here. Okay, got it. So they put in some screws from the other side. But anyway, it's really well made. I like the way they just use one of those standard cases and got the best out of it. See, there will be some test. So just stick in some capacitors here if you want to. But I must say, I'm really impressed about how much electronics they stacked into this little. Oh, look at that one. It's a dual gate MOSFET thingy. Nice. Yeah, you can also see the layout here. So it's full of analog transistors and all sorts of things. Amazing, it really works. Tiny little component right there. Yeah, it's just beautiful. But there isn't really anything I can do to fix this. There's some, there's also some foam under here, and you can even see how bent the whole thing is here on the PCB, and so it looks like we got glue here. So this socket was probably glued or soldered into the PCB, and then the glass just sticks in, right? So this is probably not glued on this side. No, you can move it. I didn't expect that. Yeah, there's no way to fix this. I can also see some foam. Ooh, this foam is not supposed to. Ooh, this is all swollen and. Ooh, yo. So maybe this is what is causing the mechanical problem from the weir. I'll try and fix this and see if it works. There's no way I can fix this. Also, if you look real careful, this epoxy fix here is actually somebody who fixed this, and they put in a little piece of wood to press the display in the right direction. And they also bent one of the pins here in the connector. So this was definitely attempted a repair many years ago. So there's no more to say about this unit. It still kind of works and you can still read the numbers, but okay, the display is not super duper beautiful anymore. That's just too bad. And that bulb is really something. I haven't seen that before. It's looking like, oh, this is in series with a trimmer and stuff. So this is probably some part of the oscillator circuit. Really? Because I have seen bulbs in oscillators. That is a very known way to keep levels accurate. But in meters like this, I think this is the first time. So I'm about to assemble this, and look, I did see a little bit of wet puke down here, and then I take out the batteries. I don't know if you can see how wet it is, but everything here is wet and puked. And one of the cells here is completely puked. See, wet and juicy. Ugh. See, now I need to clean up here and everything. Oh no, all this. So maybe all this acid vapor in here attacked the LCD and broke the LCD. Ew. I'll try and clean this up a little bit.